Here are the top 10 things you need to know about fractions. Must know number 1. What is a fraction? A fraction is a way of expressing parts of a whole. And then a fraction looks like this, where we draw a horizontal line, which represents a division operator. And then above the horizontal line goes a number which we call the numerator of the fraction. And below the horizontal line goes a number which we call the denominator of the fraction. Now, the denominator actually represents the total number of equal parts that the whole is divided into. And the numerator represents the number of parts of the whole that are being considered. So let's try an example now where we will create a fraction. The example says, what fraction of the shape is shaded? Well, I see that I have a square that has been divided into 4 equal sections. And of those 4 equal sections, I see that 3 of them have been shaded in. So to represent this as a fraction, I'll draw my horizontal line. And then in the denominator, since the square has been divided into a total of 4 equal parts, I'll write a 4. And then since we're considering what fraction of the shape is shaded, in the numerator will be the number of parts that are shaded in. And I see 3 of them are shaded in, so 3 goes in the numerator. So our answer is 3 over 4, which can be read as 3/4. And we interpret it to mean that 3 out of the 4 parts of the square are shaded. Must know number 2, reducing fractions. Reducing a fraction involves simplifying it to the form where the numerator and denominator are as small as possible, but still maintain the same proportional relationship. So before I teach you how to reduce fractions, let me show you why 1 over 2 is the equivalent but reduced version of 2 over 4. Now let me try and give you a visual representation of both of these fractions. So for each of the fractions, notice that I drew rectangles of equal size, but in this rectangle, I divided it into 2 equal parts and then shaded in one of those 2 equal parts. But for this rectangle, I divided it into 4 equal parts and then shaded in 2 of those 4 equal parts. And hopefully you can see that if I were to move these rectangles, so they're right on top of each other, that the exact same proportion of each of those rectangles have been shaded in, which should tell you that the fraction 1 over 2 is equivalent to the fraction 2 over 4. But this fraction, the numerator and denominator, the numbers are smaller. This is the reduced but equivalent version of 2 over 4. And now let me show you a couple different methods for how you can reduce fractions. So I'll get rid of this demonstration. Let's look at how we can reduce the fraction 24 over 36 using 2 different methods. Method 1 is the greatest common factor method, and method 2 is the prime factorization method. Let's start with method 1, the greatest common factor method. For this method, we just have to divide both the numerator and denominator by the biggest factor that they have in common. So let's make lists of the factors of both 24 and 36. Now, in those 2 lists, we just have to find what is the biggest number that those lists have in common. 12 is the biggest number that divides evenly into both 24 and 36. So then what we do is divide both the numerator and denominator by 12. Now let me move this over so I have a little bit of room to write my reduced but equivalent version of this fraction. 24 over 36 would be equal to, well, 24 divided by 12 is 2. And 36 divided by 12 is 3. So the fractions 24 over 36 and 2 over 3 represent the same proportion. They have the exact same value. Just 2/3 is the reduced version of 24 over 36. And now let me show you how we can get that same reduced answer using method 2, which is prime factorization. So I'll move this over a bit so I have room to actually rewrite both the numerator and denominator as products of their prime factors. Starting with the 24 that's in the numerator, I could write it as a product of the factors 2 and 12. Now, those aren't the prime factors. 2 is prime because the only numbers that divide evenly into 2 are 1 and itself, but 12 is not prime. So let me rewrite this 12 as a product of the factors 3 and 4. Now, 3 is a prime factor because the only numbers that divide evenly into 3 are 1 and 3. But 4 is not a prime factor. 4 could be written as a product of the factors 2 and 2. And now this is the complete prime factorization of 24. It's a product of only prime numbers. Now let's find the prime factors of 36. I could start by writing 36 as a product of 3 and 12. 3 is prime, but 12 is not prime. So I'll break 12 up into a product of 3 and 4. And then 4 is not prime, so I'll break that into a product of 2 times 2. And here's the full prime factorization of 36. And now what we look to do, are there any factors in the numerator that can cancel out with any factors in the denominator? Well, I have a 3 being divided by 3, that's 1, so I can cancel those factors. 2 divided by 2 is 1, so I can cancel those factors. And same with this pair of 2's. So notice all we have left in the numerator is 2, and all that we have left in the denominator is 3. So this fraction would equal 2 over 3, which is the exact same answer that we got using the greatest common factor method. Must know number 3, multiplying fractions. The rule for multiplying fractions is that if you have the fraction a over b being multiplied by the fraction c over d, the product of those fractions would just equal a times c over b times d. So simply put, when multiplying fractions, you multiply the numerators a times c, that becomes the numerator of your product, and then you multiply the denominators b times d, and that becomes the denominator of your product. And then let's do some examples of multiplying fractions. And there are actually 2 different ways we can go about multiplying fractions. So I'll break it up into 2 different parts here. So notice we have 2 methods for multiplying fractions, direct multiplication and cross cancellation. They both use this rule, but they are slightly different because in direct multiplication, we multiply first and then reduce our answer. But in cross cancellation, you do any reducing first and then find your product. So let's do a few examples of each. Starting with example 1, where we'll use direct multiplication. To find the product of these fractions, I just have to multiply the numerators, 3 times 5, and divide that by the product of the denominators, 4 times 6. And then if I find these products, 3 times 5 is 15, and 4 times 6 is 24. But then this fraction, I have to check if it reduces. I'll check for what is the biggest number that divides evenly into both 15 and 24. And that number would be 3. So I could divide both the numerator and denominator by 3. And when doing that, I get my final reduced fraction. 15 divided by 3 is 5, and 24 divided by 3 is 8. Now let me show you how we could get this same answer of 5 over 8 using the method of cross cancellation. So I'll write this same example. Now when we did this example with direct multiplication, we did the multiplying first and then reduced the fraction. But what we could do instead is check for any factors that reduce before doing the multiplying. And when multiplying fractions, not only are we allowed to cancel factors within their own fraction, but we're also allowed to cross cancel. That means we're allowed to check if any of the factors in either of the numerators cancel out with any of the factors in either of the denominators. We're allowed to even look across between the 2 fractions. So for example, if I look at this factor of 3 that's in the numerator, and this factor of 6 that's in the denominator, I know that they have a greatest common factor of 3. So I could divide both of those numbers by 3 to simplify this product. 3 divided by 3 is 1, and 6 divided by 3 is 2. And now I can find the product by multiplying the numerators, 1 times 5, and dividing that by the product of the denominators, 4 times 2, which gives me 5 over 8, which notice is the exact same answer we got by doing direct multiplication. Let's do one more where we do both methods. In this example, we have a fraction times a whole number. It might be helpful if we rewrite that whole number as a fraction 8 over 1, which is equivalent to 8, right? Because 8 divided by 1 is 8. And then when using the method of direct multiplication, I know I can find my product by multiplying the numerators, 5 times 8, over the product of the denominators, 6 times 1. And that gives me 5 times 8 is 40, and 6 times 1 is 6. So I have 40 over 6, but that fraction can be simplified. It can be reduced. I know that 2 divides evenly into both 40 and 6. So I'll divide them both by 2, and that will give me my equivalent but reduced version of the final answer. 40 divided by 2 is 20, and 6 divided by 2 is 3. And then let's try this same example again, but this time let's use the method of cross cancellation. Once again, it may be helpful to write this whole number as a fraction over 1, and then we check are there any factors in the numerator that reduce with any of the factors in the denominator. Well, I know that 2 divides evenly into both 8 and 6, so I'll divide them both by 2. 8 divided by 2 is 4, and 6 divided by 2 is 3. And then I can find this product just by multiplying the numerators, 5 times 4, and dividing that by the product of the denominators, 3 times 1. And this gives me 5 times 4, which is 20, divided by 3 times 1, which is 3. Notice the same answer we got when we did direct multiplication. Must know number 4, dividing fractions. The rule for dividing fractions is that if you have the fraction a over b being divided by the fraction c over d, we can actually rewrite this as a product where we keep the first fraction the same, but then we change the division operation to multiplication, and we multiply by the reciprocal or the flip of the second fraction. So instead of c over d, if we flip it, it becomes d over c. So simply put, you keep the first fraction the same, change division to multiplication, and flip the second fraction. Keep, change, flip will help you remember how to divide fractions. And then after you've written it as a product of fractions, well, you know how to multiply fractions. You just multiply the numerators, a times d, and put that over the product of the denominators, b times c. Now let's practice that rule with 2 examples. Starting with example 1, whenever we're dividing 2 fractions, the first thing you can do is change it to a multiplication question. By keeping the first fraction the same, change division to multiplication, and do the reciprocal of the second fraction. That just means flip it. So instead of 5 over 8, if we flip it, it becomes 8 over 5. And now that it's a product of fractions, we can look to reduce in this step before multiplying, or we can multiply first and then reduce. I think what I'll do is do direct multiplication here. I'll do the multiplication first. To find this product, I know that I multiply the numerators, 3 times 8, which is 24, and divide that by the product of the denominators, 4 times 5, which is 20. And then this fraction reduces because I know that 4 divides evenly into both the numerator and denominator. So if I divide them both by 4, I would get 24 divided by 4 is 6, over 20 divided by 4 is 5. So my final reduced answer is 6 over 5. Let's see if we can do example 2. I have 2 over 7 divided by 4. It might be helpful whenever working with fractions, if you have a whole number, think of it as a whole number over 1. So I can change that 4 to 4 over 1. And then to evaluate this, the first thing we'll want to do is change it to a multiplication question. And to do that, I know that I keep the first fraction the same, change division to multiplication, and flip the second fraction. So instead of 4 over 1, it becomes 1 over 4. And then why don't I look to do my reducing before doing the multiplication this time? I notice that I can reduce this 2 over 4. 2 divides evenly into both of those numbers, so I could divide them both by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So that 2 over 4 reduced to 1 over 2. And now I can do my multiplying. In the numerator, I have 1 times 1, which is 1, and that goes over the product of the denominators. 7 times 2 is 14. Must know number 5, adding and subtracting fractions. The first thing you have to know about adding or subtracting fractions is that you must convert each fraction to an equivalent fraction with a common denominator. And then once you've done that, the rule for adding or subtracting fractions with a common denominator would be that if you have the fraction a over b plus or minus the fraction c over b, notice these fractions have the same denominator, the denominators are both b, the sum or difference would be equal to a single fraction where you keep that common denominator of b, and then you add or subtract the numerators. So you'd have a plus or minus c. So let me show you how that rule works with a couple examples. In this example, we have 2 over 7 plus 1 over 7. Notice those fractions have a common denominator, which means to find the sum of those fractions, all I have to do is find the sum of the numerators, 2 plus 1, and put that over the common denominator of 7. So 2 plus 1 is 3, so this would equal 3 over 7. Let's try another example where we don't have common denominators. In this second example, we have 5 over 6 minus 1 over 3. The first thing you should notice is that the denominators are not the same. So before being able to subtract these fractions, we need to get a common denominator. And to choose a common denominator, it's best if we choose the lowest common multiple between 6 and 3. So if I were to list the multiples of 6 and the multiples of 3, I would notice that the smallest number in common between these lists is 6. So 6 would be the lowest common denominator between these two fractions. Also notice there's another number in common between these two lists, which is 18. And it's no coincidence that that is the product of the denominators. The product of the denominators would always be a common multiple of the two numbers, but it's not always the lowest common multiple. And it'll make your life easier if you choose the smallest number in common between these lists. So we will make our common denominator for these fractions. We'll make the common denominator 6. In this fraction, the denominator is already 6, but in this fraction, the denominator is 3. So to make that 3 be a 6, I would have to multiply it by 2. And in order to keep this fraction equivalent to 1/3, I would also have to multiply the numerator by 2. So really what's happening here, when we have that 1/3 multiplied by 2 top and bottom, I could rewrite it in a different format. I could write it as 1/3 times 2 over 2. Just to make it obvious to you that what we're doing is just multiplying by 2 divided by 2 is just 1. So we're just multiplying that 1/3 by 1, which is not changing its value. It's just writing it in an equivalent but different format. So I'll write it back the way I had it before, and now I'll start simplifying this. I have 5 over 6 minus 1 times 2 is 2, and 3 times 2 is 6. And now that I have a common denominator, I can subtract the fractions. And to subtract the fractions, I just have to subtract the numerators. 5 minus 2 is 3, and then keep the common denominator of 6. And then this fraction reduces. 3 divides evenly into both 3 and 6. So I'll divide the top and bottom of this fraction by 3, and that would equal 3 divided by 3 is 1, and 6 divided by 3 is 2. And let's try one more example where we have a whole number. In this example, we have 2 plus a quarter. When we have a whole number, such as 2, it would be useful to think of that as being a 2 over 1. And when adding fractions, we need a common denominator, and right now, they're not the same denominator. So I need to find a common denominator between the numbers 1 and 4. The lowest common multiple between 1 and 4 is the number 4. So I can make this denominator be a 4 by multiplying it by 4, and then to keep the fraction equivalent, I would also have to multiply the numerator by 4. And then this would equal, I have 2 times 4, which is 8, over 1 times 4, which is 4, plus 1 over 4. Now that I have a common denominator, I can get my answer just by adding the numerators. 8 plus 1 is 9, and putting that over my common denominator of 4. And that fraction doesn't reduce, so that's my final answer. Must know number 6. Mixed and improper fractions. So there are actually 3 main types of fractions: proper, improper, and mixed. Now let me quickly tell you the difference between the 3 of these and then how we can convert between them. A proper fraction is of the format a over b, where the number in the numerator, a, is less than the number in the denominator, b. And then a quick example of that would be the fraction 3 over 5, where an improper fraction is also of the format a over b, but this time the number in the numerator, a, is bigger than or equal to the number in the denominator. So an example of an improper fraction would be the fraction 10 over 7. And then a mixed fraction looks like this format, where we have some whole number c, and then beside it we have a proper fraction a over b. And then an example of a mixed number could be the number 2 and 5/8. And it's also worth noting that in this notation, let me zoom in a bit, this is not 2 times 5/8. It's actually 2 and 5/8, or a better way of putting it is 2 plus 5/8. So now let's work at converting between a mixed fraction and an improper fraction. So for example, if we had the mixed fraction 4 and 2/5, we can actually write that as an improper fraction by finding the product of the whole number and the denominator, 4 times 5, and to that product, add the numerator of the proper fraction, so add 2, and put that all over the denominator of the fraction, which is 5. And then this would simplify to 4 times 5 is 20, plus 2 is 22, over 5. So if I were to write this rule out in words, to get that improper fraction, I do the whole number of the mixed fraction, multiplied by the denominator of the fraction, and then add the numerator, and put it all over the denominator of the fraction. If you forget this rule, what you could actually do is you could just rewrite that mixed fraction. You could rewrite it as an addition question if you wanted to. You could write it as 4 plus 2/5. And 4 is actually 4 over 1. And if you got a common denominator by multiplying this fraction by 5 top and bottom, this would equal 20 over 5 plus 2 over 5, which is, of course, 22 over 5, which is the same value we got using the rule for converting from a mixed to an improper fraction. So I'll erase that, and we'll go ahead and try and go the other way. What if we wanted to go from an improper fraction to a mixed fraction? Here's an example. I have the improper fraction 8 over 3, and I want to write it as a mixed fraction. To do that, I actually have to be able to do a division. I need to do 8 divided by 3 and see what my quotient and remainder are. So I could set up a long division table, and then 3 goes into 8 2 whole times. 2 times 3 is 6. And then when I subtract what's in my dividend, I see that I have a remainder of 2, which means that 8 over 3 can be written as, well, it goes in 2 whole times, and then because my remainder is 2, it goes in 2/3 of another time. And the rule I'm following to write that as a mixed fraction is I'm writing the quotient as the whole number of the mixed fraction. So in this case, my quotient was 2, so that becomes the whole number. And then the proper fraction that goes with that mixed number is the remainder over the denominator of the fraction. Since my remainder is 2, I put that over the denominator, which was 3, to get 2 and 2/3. Must know number 7. Percent. A percent is a special type of fraction where the denominator is 100. And the percent symbol just means parts per 100. So let me show you how we can convert a percent into a fraction and vice versa, a fraction into a percent. Let's start by turning a percent into a fraction. So let's say we had 75%. This percent symbol means that we have 75 parts per 100. So I could write this as a fraction as 75 over 100. And then that fraction can be reduced. The greatest common factor between 75 and 100 is 25. So I can divide both the numerator and denominator by 25. And that would give me the equivalent but reduced fraction of 3 over 4. Now how about if we start with a fraction and want to convert it to a percentage? Let's say we have the fraction 3 over 20. If you'd want to convert this to a percent, the first thing you'd want to do is convert it to a decimal value by doing the division. You could do 3 divided by 20. And you could do that using a calculator or by doing long division. And you would find out that its decimal value is 0.15. And to get a decimal value converted to a percent, all you have to do is multiply it by 100, which would make this equal 15%. Now this middle line is a little bit misleading. What's actually happening here is that 0.15, if we were to think of that as a fraction, it's 0.15 over 1. And to be a percent, we know we want the fraction to be over 100. So we would need to multiply the top and bottom of this fraction by 100. So really we're multiplying it by 100 over 100, which would make it equal to 15 over 100. And we know when we have a fraction that's over 100, we could write it as a percentage. 15 over 100 is 15%. But usually all of these steps aren't communicated. You just have to know that if you have a decimal value and you want to convert it to a percentage, just multiply that decimal value by 100 and it gives you the percent value of that decimal. The other way you could convert a fraction to a percent, let's work with 3 over 20 again. Because we want this fraction to be over 100 so we can express it as a percent, I would just notice that I could make 20 be 100 if I multiplied it by 5. So I could just multiply the top and bottom of this fraction by 5. And that would give me the fraction 15 over 100, which is 15%. Must know number 8. Equations involving fractions. I'm going to solve two equations that both involve fractions. And before we solve these equations, let me give you a tip. When solving equations involving fractions, you can just multiply both sides of the equation by the lowest common denominator of all the fractions to eliminate them. So let's start with example 1, where I see I have two fractions that are equal to each other. The denominators of the fractions are 5 and 3. So one option I have is I could get rid of those fractions by multiplying both sides of this equation by the lowest common multiple of 3 and 5. If I were to list the multiples of 3 and the multiples of 5, I would see that the lowest common multiple between 3 and 5 is 15, which is also the product of 3 and 5. Find the product of the denominators will always find you a common multiple. It just might not always be the lowest common multiple. So what I can do is multiply both sides of this equation by 15. And now on the left and right side of the equation, I have a product of fractions. So I can cross reduce. 15 divided by 5 is 3. And 15 divided by 3 is 5. So notice my fractions are gone now. On the left side of the equation, I just have a 3 times x. And on the right side of the equation, I have 5 times x minus 2. And there's actually a shortcut for this question. If you had have noticed that we had a fraction equal to a fraction, you could use a method called cross multiplication to jump right to this step. All you would have to do would be to find the product of one denominator with its diagonally opposite numerator and set one side of the equation equal to that product. And then the other side of the equation would be equal to this denominator times its diagonally opposite numerator. So 3 times x is what the other side of the equation is equal to. But only use that shortcut if you have a fraction equal to a fraction. And now we need to solve this equation. So I would use the distributive property to expand the right side of the equation, which would give me 5x minus 10. And then I would continue solving by getting the variable terms to the right side of the equation and the constant term to the left side of the equation. So I have 10 is equal to 2x, which means if I divide the 2 to the other side, I would find out that x is equal to 5. And don't forget, when solving any equation, you can check your answer by subbing it back into the original equation for x and make sure left side equals right side. Let's now try and solve equation number 2. I see 3 fractions. So what I can do to get rid of those fractions is multiply both sides of the equation by the lowest common multiple of all of the denominators. The lowest common multiple of 2, 3, and 6 is 6. So I'll multiply both sides of this equation by 6. On the left side of the equation, I'll have to distribute the 6 to both terms. And now I can start reducing these fractions. 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 6 is 1. So on the left side of the equation, I have 3 times x plus 2 times 1. That's just going to be 3x plus 2. And then on the right side of the equation, I just have 1 times 1, which is 1. I'll isolate the variable term by moving the 2 to the other side. So I have 3x being equal to negative 1. And then if I divide the 3, I find that x is equal to negative a third. Must know number 9, fractions in the exponent. So in this section, I want to show you what to do if you have a power with a rational exponent. And the rule, if you're taking the nth root of a power a to the m, this can be written as a power with a rational exponent, where the base is still some number a, and the exponent becomes the fraction m over n. So let me give you a few examples where we can work with some powers with rational exponents. Let's start with example 1, where I have the power 8 to the exponent of 2/3. If I wanted to evaluate this without a calculator, what I could do, using my exponent laws for a power of a power, I could rewrite this as 8 to the power of 1/3 squared. And then when evaluating 8 to the power of 1/3, What that means is 3 factors of what number multiplied together is equal to 8. Well, I know 2 times 2 times 2 is 8, which means 8 to the power of 1/3 is 2. So we have 2 squared, which is 4. In example 2, I have the 4th root of this fraction. I could rewrite that expression as a power with a rational exponent. It would be 16 over 81 to the power of 1 over 4. This small number with this root symbol is called an indice of the root, and it becomes the denominator of the fraction that's in the exponent. And then using my exponent rules, I know that exponent of 1 over 4 would be applied to both the 16 and the 81. And an exponent of 1 over 4 just means 4 factors of what number multiplied together is going to equal the base of the power, 16. Well, 4 factors of 2 multiplied together is 16, so my numerator is 2. And in the denominator, 4 factors of what number multiplied together is 81. Well, 3 times 3 times 3 times 3 is 81, which means 81 to the power of a quarter is 3. So the 4th root of 16 over 81 is 2/3. And then example 3, I have a y squared that I'm taking the 5th root of. That 5th root symbol can be rewritten as a rational exponent. I could rewrite this as y squared to the power of 1 over 5. And then using exponent rules, I could multiply those exponents together to get y to the power of 2 over 5. And similarly with example 4, I need to do the 4th root of x cubed y squared, which means I would have x cubed y squared to the power of 1 over 4. And when you have a power of a product, that exponent applies to both factors of the base. So I would have x cubed to the 1/4 and y squared to the power of 1/4. And multiplying the exponents together, I would have x to the 3/4, y to the 2/4. But of course, 2/4 could be reduced to a half. Must know number 10. Rationalizing the denominator of a fraction. In this section, I'm going to show you how you can rewrite a fraction so that the denominator no longer contains a radical. And there are 2 main ways we can rationalize a denominator. I'll give you an example of both. Looking at this fraction in example 1, I see the denominator is the square root of 5, which is an irrational number. But typically in our fractions, we want the denominators to be rational numbers. That's why it's called rationalizing the denominator. And how we can do that is we can multiply top and bottom of this fraction by the radical that we have in the denominator. So I can multiply top and bottom of this by root 5. So I'm multiplying this by root 5 over root 5, which is just 1. So we're not changing the value of the fraction. But when I do the multiplications, in the numerator, I have 3 times root 5, which I would just write as 3 root 5. That's an irrational number still, but that's okay. In the denominator, I have root 5 times root 5, which is the square root of 25. And the square root of 25 is the rational value 5. So this fraction has the exact same value as 3 over root 5, but the denominator is now a rational number. So the denominator has been rationalized. Now let's look at example 2, where in the denominator, we still have this irrational number root 5, but the denominator is now a binomial. It's root 5 plus 2. The strategy when we have a binomial in the denominator that needs rationalized is called multiplying by the conjugate. And what that would look like, we would multiply top and bottom of this fraction by this same binomial, but we would change the sign. So instead of plus, we're going to write minus. And then in the numerator, I have 3 times root 5 minus 2, which I'll just leave it as that product. And then in the denominator, I have root 5 plus 2 times root 5 minus 2. That's actually a difference of squares. And in case you don't remember the rule, I'll write it up top here. If you have an a minus b times an a plus b, if we were to expand that out, it would simplify to just a squared minus b squared. And that's exactly what we have with this product. The binomials look exactly the same, but their signs are different. So I know when I do the multiplication of root 5 plus 2 times root 5 minus 2, it's going to equal the square root of 5 squared minus 2 squared. And then if I simplify this fraction in the numerator, I could distribute the 3 to give me 3 root 5 minus 6. And in the denominator, I have the square root of 5 squared. Square rooting and squaring are inverse operations, so they're going to cancel out in this circumstance, and that's just going to be 5. And then I need to subtract 2 squared, which is 4. So notice the denominator is now a rational value. The denominator is now actually just 1. So my final answer would just be 3 root 5 minus 6 over 1. But when dividing by 1, we don't have to write it because it doesn't change its value. So my final answer is just 3 root 5 minus 6. So hopefully if you followed along with this whole video, you feel a lot more comfortable now working with fractions and you understand how they work. Let me know what you want a top 10 of next.
Jensen!